Hi, in this video, we will quickly go through the problem of recommendation system, which is recommending an item to a user in place of another item, but it should be personalized and interpretable. What do we really mean by that is a user who is browsing iPhone 11 Pro, we can recommend to the user Samsung S10 if we find out that for that user the camera is an important attribute. Likewise, for some other user, we might instead recommend a iPhone only of a higher range if we understand that the preference was the brand itself, right? So the key idea is to represent or to recommend a substitute of another product. We need to understand which attribute is important. So traditionally in recommendation systems, we make a user item matrix and we try to factorize those metrics to have some latent variables, and then we solve for the optimization problem of predicting the user item matrix values, right? But that will give very uninterpretable output, right? That doesn't consider the attribute, the realistic attributes into picture, right? It won't serve the purpose. So the key ideas here in this paper is that when you are browsing a specific type of product, we will need to have few set of information, right? What is that set of information? We can see in the contributions of the paper, right? So the first one is that it should be personalized and interpretable. So which means that it should take some real world attributes. So we will have a user to attribute and item to attribute matrix where these attributes would be carefully defined or extracted. That will be the collaborative filtering model. So when we do this sort of recommendation, substitution recommendation, we will be taking in account both the things, how items are similar and user preferences to those similars, right? And the third key thing is we can still have, we would have still done, would have done that with traditional methods, but here we'll be taking some explicit attributes A in interest of interpretability, right? So that's what the paper contributes. And in summation, if we see this paper, basically the key part is that it uses something called as centiers. Centiers, if you see, is basically a NLP toolkit which does phrase level sentiment analysis. So you can give it any phrase, okay, and it will give you such triplets, right? It will analyze, and these phrases should be user ratings, okay? So it gets sentiments out of user ratings corresponding to attributes, right? So battery life was short, so it was negative, right? So it extracts triplets such as feature, what was the user opinion, and sentiment. And these feature, if you might have realized, becomes our attribute, right? So we, for every review, we can have this sort of user review, we can have this sort of attribute listed, and then we can make two matrices. First matrix is the user attribute matrix for which what we do is for each user and for each attribute, if user never mentioned in any of the reviews, it would be zero. If the user mentioned it in some of the review, right, we'll replace it with this value denoting the strength of importance that user has placed to this particular attribute, right? So user attribute matrix, each element will tell you how much importance did the user give to this attribute. Similarly, a matrix y of dimension v cross a, which is number of items from cross attributes, will represent for this item and this attribute what was the average user feedback, right? So that's another metric. So now we have our two matrices x and y, right? Now what we really do is we need to do some collaborative filtering, and we can train a model to predict to understand these user attribute relationships, right? So we define first loss as LUA for user attribute metrics, where XIN is the actual value of the user attribute metrics that we know, and XIN would be the model predicted value, right? So we want the model to learn the close representation of that matrix, where DUA is the set of all the populated values, right? Likewise, we'll have, like we have LUA, we'll also have LIA. This is at the item level, right? So we need to optimize for these two losses together, which is LUO and LIA. And how does this paper do is it trains a neural network basically. It concatenates the the user it concatenates two things, which is the user vector and the attribute vector, UI and AN. So these are provided as input to the model, right? So for a given user and for a given attribute, right? So if we see here, um, so both user and attribute embeddings. So user I and AN, right? Both of them will be the initialization parameter, right? So these attribute pairs, again, if for this, it would be item in the attribute embedding, right? So if we say whose input is a concatenation of item embedding and the attribute embedding, right? VJ and AN. So we provide these sort of inputs to the neural network. We train two neural networks which have a different set of weights and bias, but they for weights and bias for LIA and LUA, but we basically optimize the global loss function here, in which case, in this case, it is, if we see here, let me just find the optimization function we are solving for. So it will be in the optimization section, which is here. So we solve for the combined loss, right? Likewise, we make this model and then we use the same model to predict the missing values. X, let's call them X tilde and Y tilde, right? So these metrics get populated. Now we have a complete set of metrics, right? Now, once we have this populated metrics from this neural network, we also get attribute embedding, right? Via the hidden layers. We understand some of those embeddings, right, which we can also share in this case because it both are conveying like similar properties. So once we have that, what we do next is we need to solve for the substitution and personalized recommendation problem, right? So there's an algorithm called BPR, which is a Bayesian algorithm for recommendation, but on a high level, what we do is we try to minimize this function. We want to get to a function f that, given a user, given an item he visited, and given another item that he clicked historically from a database, and another function which this provides the likelihood of this action, and this is the likelihood of VJ negative, which is any other item which he didn't pick, right? And we want to maximize the log difference of it, which we call as LBPRS, right? So once we have this matrix, what we do is we, as I was saying earlier, in optimization, first we minimize this and then we minimize LBPRS, right? And this minimize, after minimizing, this is again another set of neural network to minimize LBPRS, which is a recommendation loss. And then the entire model's training is completed. So this is how in Summit works. There are a few constraints that we apply to make sure, using the embeddings of the neural network, to make sure that we are correctly weighting the substitution constraint, which is like correct item should be substituted, and also the personalization constraint, which is like the user likability to it, right? So this is how it does. So we can now, since we have these explicit attributes, we can infer the importance of each attribute. Right? So this is what this paper does. It basically summarizes that it gets good results, and that's the novel contribution of this paper.